start discussing the things which we have talked in the last session. So, the last session we have just gone through the brief history of the development of the prestressed concrete, even right from the inception. The right from the concrete itself. Uh, this was just to run through the slides. What happened in the last session? So it actually started in 1824 with the OPC uh, to get a patent from the aspirin. After that, the development has been taken place in terms of steel, then further into pre-stressing. Likewise, one after the other, the things have been taken up, and it almost took 100 years to actually go to the pre-stressed concrete, full-fledged pre-stressed concrete by Fressinet, who started the devising the pre-stressed concrete for mass development of the pre-stressed concrete members and pre-stressing technology. Then after that, Hoyer, Magnell, and some other scientists have been very active in this area, so that yeah, this was later part of the history. When it comes to India, when this pre-stressed concrete is being effective, it was the first pre-stressed concrete bridge was built in 1948 under the Assam Rail Link project. So this is where the pre-stressed concrete bridge construction has taken place in India. And later on, it went on. The classic example is Pamban Road Bridge at Rameswaram, which is in Tamil Nadu. Okay, so this is where the India has started the pre-stressed concrete applications, and you could see the Pamban Road Bridge at Rameswaram, a picture of it, and how the development of materials, I have put it in consolidated format. So where the building materials, when you see ancient period, the stones and bricks were extensively used. All our monuments and the age-old temples of thousands of years age, you can see they are built with stones and bricks. These materials are strong in compression but weak in tension. So for tension, they used bamboos, kai ropes for bridges. So this you can see the bamboos and kai ropes for tension, which is used for bridges. You can see in Hollywood movies, old time uh, bridges that the kai ropes used to, uh, made from these bridges made from the kai ropes. Subsequently, the iron has come and the steel bars were used to resist tension. These members tend to buckle under compression. Okay. So problem with the stones and bricks is they are weak in tension. Problem with the steel it is going to buckle under compression. Then wood and structural steel members were effective both in tension and compression. So in reinforced concrete, concrete and steel are combined such that uh, to have resistance over compression and steel. So this is what we call the passive combination of two materials, which means the purpose of one material is for one activity and the purpose of other material is for other activity. That is what is called passive combination. Okay, so reinforcing the steel into the concrete to counteract the weakness of the materials. And in prestressed concrete, high strength concrete and high strength steel are combined such that full section is effective, resisting both in tension and compression. So, which is called an active combination of the two materials. So, we have been using in RCC a passive combination where for the purpose of one material is exclusively for resisting one particular force. So that is made active by pre-stressing the concrete. The concrete's the weakness in taking tension is enhanced, and the high tensile steel is used for this purpose. So that is where you have active combination of the materials. Okay, and this will show you the development of the materials over time. So when you take compression to resist compression, we were using stones and bricks in ancient constructions. Then later on, the concrete has come, and then the high strength concrete. So this is where you are now. And for resisting tension, bamboos and coir ropes were used in the ancient times. Then the material steel bars came in, wires. Then high strength steel is the today's technology. Right, for both compression and tension, the timber was the material which was used. Then structural steel materials is the next thing to be used, and reinforced concrete. Finally, the pre-stressed concrete is the one which is the active combination of the materials to resist both compression and tension. So this is how the development of the materials. So where you are now, that means today's technology is to use pre-stressed concrete for both resisting compression and tension. Okay, so we are in the stage of switching over to this RCC to PSC. We will see the application part and advantages, disadvantages, all that. Okay, so this picture will give you the idea of how the materials have been developed from the ancient times to till date. Okay, right. What will be the forms of pre-stressing steel? How do we use pre-stressing steel in what form? So it started with a wire. So first a wire is stretched, as you can see. We have discussed in the history of pre-stressed concrete, where initially the flower parts were made by pre-stressing the concrete with the wires, steel wires. Okay, So pre-stressing wire is a single unit made of steel. So wire, okay, 2, 3 or 7 wires are wound to form a pre-stressing strand. So when you take 2 wires or 3 wires or 7 wires and then you wound to form a pre-stressing strand. So twisted. So that is called strand. So what does it mean? A strand means 2 or more steel wires. When you combine them, we will call it a strand. Tendon. What is meant by a tendon? A group of strands, okay, are wires wound to form a pre-stressing tendon. Right? So, 2 or more such strands, if you twist them to form a uh, tendon, to form a thing called, which is called tendon. Okay. So, what next is the form of pre-stressing steel which is used? A cable, a group of tendons, a group of such 2 or more such tendons are called a cable, pre-stressing cable. Okay, so pre-stressing wire, pre-stressing strand, pre-stressing tendon, a pre-stressing cable. Okay, the tendon can be made up of a single steel bar. The diameter of the bar will be very larger when compared to the wire. Okay, so these are the forms which we will use in pre-stressing. So a wire can be used, a strand, depending on the amount of force that you want to induce in the concrete. The amount of force, if the amount of force is less, we go for a wire. The amount of is little uh, higher value, we go for strand. Still more little higher value, tendons. Much more force to induce, we go for cables, pre-stressing cables. Okay. So likewise, this is the form of pre-stressing steel that we use for pre-stressing. Okay. A wire or a strand, a tendon, a cable, a bar. Okay. So this is about pre-stressing steel, in which form we are being used, right? Then a nature of concrete steel interface. Mean RCC, you see reinforced concrete. So what you do, we take a mold. In practical point of view, if you say, we put the formwork, then we place the steel reinforcing bars, and we make the concrete. We pour the concrete, and concrete is set, and the steel and concrete will be in bonded form with the gel formation of the concrete. The gel and the steel bar, reinforcing bar will be in condition of bonded nature. So that will be of, in case of pre-stressed concrete, that is one aspect, having a bonded tendon, or it can be a unbonded tendon also. So that we will see. So you have two such steel concrete interface, the joint, what you can say, the interface in the sense, the joint, steel and concrete interface, a layer of joint. Okay. So bonded tendon means when there is adequate bond between pre-stressing tendon and concrete. That is called a bonded tendon. Okay. So what you call practically a bonded tendon, which is a pre-tensioned and pre-tensioned member. Pre-tensioned members will have bonded tendons, okay, or post-tension, which are grouted, will have bonded tendons. Okay, in which case we will have bonded tendons. Okay, so bond between concrete and tendon is possible in case of pre-tensioned uh, pre-stressed members or grouted post-tensioned pre-stressed members. Okay, so this is the bonded tendon and its application are examples for bonded tendon. And unbonded, which means there is no connection between the concrete and tendon. Okay, so where it is possible, what is the example? So when there is no bond at all between the tendon and the concrete, it is called unbonded tendon. So it is possible in only one case, which is post-tensioned, ungrouted tendons will be unbonded tendons. Okay. So pre-tensioning, there is every chance of 100% bonded tendon is possible. Post tension, you can have a bonded or unbonded tendon. Post tension, there is an option. So if you use grout in case of post tension members, means the duct provided for the tendon, if it is grouted with a grouting material, then we will have bond. If it is not grouted, then we will have unbonded tendon. Okay, so there's a difference: pre-tensioned member, post-tensioned member. Pre-tensioned in the sense what, we will stretch the tendon, we will pull the tendon, hold it over the concrete, and once the concrete is set, then we will release the tendon. That is called pre-tensioning. Pre-tensioning means what? Tensioning before what? Before uh, concrete is set. Okay. Post-tensioned means what? Post means after that. After what? After concrete is set. So what do? You take a mold, first put a duct, provide a duct, means a pipe, for example, provide a pipe, okay, right? Then pour the concrete is set, then now insert the tendon into the duct, then tension it, okay, right? Uh, you may have the option now, the duct provided for the inserting the tendon may be grouted, may not be grouted, okay. So tendon is tensioned after concrete is set, called post tension. Tendon is tensioned before concrete is set, is called pretension members. Okay. So bonded, unbonded tendons are the two category based on the concrete and steel interface. How the interface is. So it can have bonding, it can have no bonding at all, right? What will be the stages of loading in case of pre-stressed concrete members? So it can have initial stage of loading, intermediate stage, and final stage of loading. So there are three different stages of loading. Okay. So initial is again divided into two stages. So during tensioning of steel is the initial stage, then at the transfer of pre-stress to concrete. Okay. So this is while manufacturing or in situ pre-stressing process. Okay. Either you can manufacture at a factory, or you can do it in situ, means at the site itself. Initially means while uh, preparing the pre-stressed concrete member, that is called initial stage. Intermediate. So this includes loads during transportation of the pre-stressed members. So this is possible only for the case of factory manufacturing, not for in situ. Even in case of in situ, where you have the pre-stressed concrete making space nearer to the site itself, this is possible. Whereas when you call in situ means the site itself, so you don't have this stage, intermediate stage. This intermediate stage of loading is only for the manufactured members. Okay, so precast, we can say precast. Okay, in the other way, for precast members. So what will be the final stage of loading? At service during operation, and ultimate during extreme events, means the extreme conditions, like in its lifetime. Okay, it is like normal, what you expected loads coming onto the structure, where during operation nominal live loads, nominal dead loads, and right, nominal wind loads likewise. Extreme means the stormic wind and earthquake, peak earthquake loads, right? So such cases. This is what is called final stage of loading. Right? So these are the three stages of loading for pre-stressed concrete members. Initial, while you prepare it, maybe pre-tensioning or post-tensioning, whatever it is. So you are applying the load on the concrete even before it is used in the structure. That is what is initial. Intermediate. You prepare the concrete member somewhere, transport it. So you are going to lift it, put it in the transporting truck, and then lift it again to the desired location. All these operations will uh, attract some loads. That is what is called intermediate stage of loading. Once you place the member in its desired position, then the service loads come into picture, like live load, dead load, and all. So that is called final stage. Okay. So preparation stage, transportation stage, and in service. In service. So three stages. Okay. So these are the stages of loading. Right. So this is how we can categorize the stages of loading. Then going for advantages of pre-stressed concrete. What are the advantages of pre-stressed concrete? Okay, so this we will discuss in the next session, right? Thank you for attending this session.